Hello everyone. Continuing with a series of lectures on this one 80 microprocessor and microcontroller system. In this video, we will be discussing on the 8051 microcontroller timer. I will be discussing on the timers of 8051 microcontroller. Um, First of all, what is a timer and what is its use over here in 8051 microcontroller, and how important it is when compared to a timer available in a microcontroller chip and chip. Actually, when you go for 8086 microprocessor, when you take a 8086 microprocessor, in 8086 microprocessor, you doesn't have any internal timers. What you need to do is that either you need to go for taking up one of the timer like the uh, 8253 or 54. 8253 or 54 has to be connected over here. That will be learned in the interface. So here it doesn't require any separate timers to be connected. Already in internal in your 8051 there are two timers named as timer 0 and timer 1. The same timer can be used as an counter also. So what is the basic difference between a timer and a counter? So timer will give you the total time duration. It will give you duration of the time. So here, when you go for counter, it will give you the count pulses. How many pulses it has counted. So the duration of time is nothing but one count pulse may have 1 second or some 1 nanosecond, whatever the time duration is there. So within 1 nanoseconds, how many count pulses are there? Or within 1 second, how many count pulses are there? That is been by the counter. So you can define these two timers or counters. You can define this timer 1 and timer 0 as a counter or a timer, as you like, as per your requirement. You can define it as a timer or a counter. If you want to find out the time duration or if you want to fix it for time duration, you can make it as a time duration. If you want to make it as a counter, you can make it. So the internal circuitry would be like this way. Obviously, we'll be discussing on the main important discussion will be on how to set this timer or a counter or in which mode you want to operate. So here there are different modes of operation of timer 0 and timer 1, how to configure and how to make use of timer 0 or maybe make use of timer 1. So this would be the internal circuitry for both the timers. So here you would be having the pins as interrupt pin would be there, which would be the given as an input to the OR gate of this one. It would be invoking this. Once you give an interrupt, it will stop this one and timer will. So here every time you will be having an oscillator will be providing the oscillations of time. So timer reset pin would be given as a handed operation. So gate pin is nothing but it is a gateway to run. So this circuitry will on and off the timers accordingly. So coming to the next one, this would be generating. Once a timer is going to be run, it would pass an interrupt to your 805 microcontroller. Automatically, it will accept the interrupt and it will run it. So in your when you want to configure your 805 microcontroller timer as a timer or counter, how to run this one, whether you are using this timer or counter, we can define it up using of these bits. Okay. So here, what you can do is that in this one you will be having a set of bits given as LSB and MSB. So here you can see same number of I'm going to say here the lower 4 bits and higher 4 bits are having similar computation M0 and 1 C or T gate. M0, M1, C or D gate. This is for timer 0 and this is for timer 1. If you want to configure your timer 0 or if you want to run your timer 0, so that would be given through this, the lower 4 bits. And higher 4 bits are used for the timer. Then first comes is the gate. What is the gate in over here? Both are having the same function. Once I define the gate for one of the timer, it is obviously for both the timers. So I will take it into consideration as only as gate. So let's take for the first of all gate. Gate is one set when the timer is enabled. Okay. And then if interrupt in is high and TRX pin is set, then automatically all those processes should be there. When set, the timer is enabled. It is ready to take the whatever the mode of operation. We can fix it up and either you can go for counting the pulses or calculating the time duration. It is ready. It is timer is in on operation. Then when it is cleared, automatically it is reset. Now comes is the C of T bar. So here, whenever you see one important, whenever a pin or any point, I mean to say any bit is been defined with like just like C or T bar. So T bar indicates this is for timer. This is when it is 0, timer will be run. And C indicates whenever you are having uncomplemented form, it is high, it is active. Low, it is inactive. When you are giving any input or any pin or any bit as complemented form, like just like T bar, it is active when you give it as 0. It is inactive when you give it as 1. That is the most important thing you need to do. So if at all these particular bits are 1 or 0, and remember here, these can be configured. Timer 0 can be configured as a counter. Timer 1 can be configured as a timer. Or timer 1 can be configured as a timer. Timer 2 or both can be used as a counter. Both can be used as a timer. Any combination you can do it. But you need to specify the bit of this one. So here, if we count the bits, so here like if I mention the bits as T0 bits, T0 dot 0, this is 1, this is 2. When you take this T0 dot 2 bit, if it is 1, it is counter. If it is 0, it is a timer. So similarly, if you go for this one, this is 3, this is 4, this is 5, and this is 6 T0. And if this T0 dot 6 is 1, indicates timer, sorry, counter. If it is 0, it is a timer. So that would be defined in this one. Next one is that mode of operation. Whether you are going for a mode 0, mode 1 or mode 2, that is given by this. Remember here, 8051 microcontroller timer 0 can operate in 4 modes. Timer 1 can operate in 3 modes. This will have a look at what the timers in after this TCON register once we discussed. So here, this is a timer control register. Previously, it is not timer mode set register. Now it is timer control register. In this timer control register, you are having totally of 8 bits. 8 bits are there. Out of these 8 bits, you can see the bits of this timer. TF1, TR1, TI1, IT1, and similarly 0 would be. All these bits with zeros belongs to timer 0. So let's take this. I will put a tick mark. This is for timer 0, timer 0. This is for timer 0, timer 0. These all are for, I will put cross mark, timer 1. 4 bits are for timer 0 and 4 bits are for timer 1. So what this each bit indicates? Overflow flag. EF indicates overflow flag. Remember this. Overflow flag is been set. So then when CPU clears, it will start up. When a timer is been overflowed, it is flagged. This bit would be set. And similarly, timer run control. When you want to run the timer or when you want to stop the timer, this would be controlled by TR bit. You face this bit like we have given the numbers. This is the accordingly it is placed in the Boolean processor. These all the special function registers. Tmod and tcon are the special function registers and this one. And interrupt enable and edge flag and control flag. These are the flags of the timer control. These are the special function registers. These are the functions of this. Next one comes as the timer modes. Timer modes, timer 0 can operate in 4 modes. Timer 1 can operate in 3 modes. One of these modes we'll just have a glance about these modes. So the first mode is 13-bit timer or counter. You can make it as mod 0. And you go for mod 1, it is a 16-bit mod. Just timer or counter. When you make it as an so the maximum count would be like this way. It can count. It not feature. Maximum count would be 16-bit timer means F52. And here in mod 2, 8-bit timer or count auto reload. Auto reload means once equal for this one, whatever the count value give it, that count value would be reloaded once again. Auto reload. And here, when you go for mod 3, you can use two 8-bit timers or count. Again, you can split it into half of the timers. Separate timer for that one, separate timer for the higher 8 bits, separate timer for lower 8 bits. That's a very good advantage. Similarly, when you go for timer 1 also, you have the same 13-bit timer, then 16-bit timer, and 8-bit timer with auto reload. It doesn't have timer, 1 doesn't have splitted of 8. So this is all about the timers. I hope you have understood the topic of timers. Next video we'll be discussing on interfacing. Thank you for watching this video.